So, hey there, Algebra 1 students. This is going to be our video for class on Tuesday, the 18th. We're going to follow kind of the same type of format that we usually do. We're going to go over the homework first. I'm going to go through the answers to those. Since we can't ask questions live, we're going to take questions over the homework on Thursday. I'll talk about Thursday class here in a minute because we're going to do something a little bit different than what I had originally thought. Excuse me. But sorry, I got distracted thinking about what I'm doing. So we're going to go over homework questions, not homework questions, but homework answers. I'm going to both say them and write them on the screen here in just a minute. Since you can't ask me to repeat stuff and whatever, so I want to make sure you get that to you clearly. And so I'm going to say the answers to the homework, and I'm going to write them on the screen. We'll go over questions of those on Thursday. That's one of the main things we're going to do on Thursday. And then I'll go through today's lessons. We're actually going to skip a few lessons. We're going to go straight to lesson 7. We're going to skip lessons 5 and 6. And then, so on Thursday, we're actually going to have class through Zoom, or we may actually use a different application. I'm kind of looking at some different options for some of that and whatever else. We may use something different than Zoom. Either way, I'll let you know what we're going to do in class on Thursday. We're going to do it virtually because Rochelle and I have decided to go ahead and cancel classes for this week in person because of health and other things. And just all of that. It's also easier for us to plan. So that's what we're going to do. So for this class on Thursday, we will go over questions on the homework. This homework, and any questions on the new homework that I'm going to assign here in a bit. And then I will also, after we go through questions on that homework, I will assign a test review. And we may do a little bit of that in class on Thursday. We'll see how much time we have. I suspect we'll spend a lot of time going over questions and homework stuff. But so you'll get assigned a review on Thursday, and then the plan right now is for y'all to take that review and do it over the weekend as your homework from Thursday, and then we'll go over the review on the following Tuesday, so a week from today, and then on the Thursday after that, we will take that test. So that is the next few days worth of a plan. Let's go ahead and dive in, and we will take a look at your homework from last time. Let me pull up. Yep. Okay. So hopefully it's going to look okay. I'm trying something a little bit different in my video setup. As you can tell, I say you can tell, we haven't done enough videos for you to be able to see anything different probably, but let's see. So here are the answers to your homework problems. We did 11 through 47 odds. So I'm going to go ahead and say them and then write them down. So the answer to number 11 was y equals x minus 5. The answer to number 13 was y equals negative 5x plus 2. The answer to number 15 was, excuse me, let's see. The answer to number 15 was y equals, got some fractions here, negative 3/4 x plus 1 1/2. Number 17 was, number 17, the answer is yes. The reasoning, I won't write all out, but the answer to number 17 without the reasoning is yes. And so the answer to number 19 is yes. And when you solve those, the slopes are negative 6 and positive 1/6, which means 1/6, which means the lines are perpendicular, right? So the answer to number 21 is, let me make sure this is still looking right. Yep, it looks like it is, I think. Blah, blah. Answer number 21 is let's see, hold on, give me half a second. The answer is they are perpendicular. Answer to number 23 is y equals 1/2 x minus 1/2. The answer to number 25 is y equals negative 3x minus 7. And let's see, the answer to number 27 is y equals 1/5 x plus 8 3/5. The answer to number 29 was y equals 2x plus 16. The answer to 31 was y equals negative 1/5 x minus 3/25. And the answer to 33 is neither. The answer to 35 was perpendicular. The answer to number 37 was neither. The answer to 39, let me flip the page, was y equals 7x. The answer to 41 was something. Where is it? 41 is not on the page. Oh, there it is. The answer to 41 is yes. And the slopes you end up with are negative 7/2 and positive 2/7. So perpendicular, right? So number 43, the answer to 43A, I should say, is somewhere else. It's in the appendix. Hold on. Whoop. That was probably crazy. I wonder what that looked like. Who knows? Let me pause the video while I get to the other page. So 43A is points. Let's see, I'm going to kind of give these in a vague way. I think y'all have graphing points down solidly, so I'm going to kind of just give you a little sketch, and if you're way off or confused, you can always ask on Thursday. So a little sketch. I mean, we're like I said, I'm doing it real rough, as you can tell. Not doing it precise at all because, like I say, you're probably good at graphing points. 43A, A is approximately right there, and point C is on the x-axis right there, and point B is in quadrant 1 up over there. So 43A looks something like that. So 43B looks, there are a lot of different ways you could write the answers here. Some ways you might put the answer is, and it's hard to see from the picture that, let's see, some things you might point out would be that segment AB. You're going to get a lot of this notation a lot more in geometry next year, but I think you can follow along with what I'm writing here. Segment AB and segment C. Oh, did I label D? D isn't on the picture. Let's see. Let me read it, and I'll tell you where it is. Segment CD. They're listing a D, but there isn't a D on A, is there? Let's see. In this problem, you will explore parallel and perpendicular lines, graph points A, B, and C on a coordinate plane. But there's no D. Oh, I see. I have to read the problem, huh? Determine the coordinates of the fourth point D that would form a parallelogram. Okay, so the important thing there is that what you would have to do is, sorry, y'all. Sorry. See, I am still recording, right? It's recording me looking like a fool. That's fine. Yeah, CD. So in order for this to be a parallelogram, and I drew this kind of crazy-fied, right? But in order for this to be a parallelogram, then AB and CD would have to be parallel, right? Which would mean that they have to have the same slope. They would have to have the same slope. So D would have to be, let's see, let me change colors. D would have to be, let me kind of dot out what's happening here. So a parallelogram has parallel lines for sides. So this would have to be something along those lines, right? So D, this is probably not drawn to scale, but D would have to be somewhere along there, right? So, excuse me. So AB and CD would have to have the same slope, and that's what's going on there. Remember that this is kind of our symbol for parallel, a crooked L sign, right? And let's see. So the other thing that would have to be true is that AC, segment AC, so this segment right here, and segment BD would also have to have, that's not what I want. There you go, stupid machine. BD would have to have the same slope as well. And so that's really the important bit of that. Let's see. So for C, you could use the slope formula to find C and all that kind of stuff, and we'll leave it at that. So let's look at 45. 45 is got several different likely answers. The important thing there is that they're both parallel lines. Pause. Yeah, so sorry, had to actually do some read what I was. I assigned some hot problems this time. The answers are not just the answer is 30 or whatever. So for 45, what I really want you to remember, they on their sample answer, which is good, they go into like the domains and ranges being the same on parallel and perpendicular lines and all that kind of stuff. They also go on the fact that they're on the same plane and all of those details that are true, and those are all really good. But the main thing that we really want to remember for this lesson is parallel lines, their slopes are the same. Perpendicular lines, their slopes are not the same. Of course, they're opposite reciprocal slopes. And those are the really important bits for that, and those are the things that we really want to keep in mind. There's a lot. I could read the full sample answer that they gave, and there's a lot of other things that are true, and that's worth noting. But the main thing that I want us to remember is that they have the same slope, not same slop. Ha 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 ha. So number 47 was the last one we did, and the answer number 47 is that Carmen did it right. Chase didn't do it right, which makes sense. I don't even know Carmen and Chase, but that totally makes sense. So those are the answers to those homework problems. We'll take questions over those on Thursday. And we'll take questions over those on Thursday. Let's dive into lesson 7. Let me pause while I get that lesson set up and ready to go. We're going to look at inverses. All right, so like I said, we are going to talk about inverse linear functions for today's lesson. And we're going to dive into that. We're going to look at it kind of algebraically and graphically as well. Excuse me. So what are inverse functions? Basically, what inverse functions are is if we have function A, excuse me, got some hiccups all of a sudden. Function A, and we have function B. Okay. Then what we do is if function B is the inverse of function A is what I'm trying to say, then what we do is we switch the x's and the y's. The domain and the range, if you will. No, stop it. Okay. Now, the notation that we use for the inverse is we use a little tick mark. So what do I mean by that? Well, we've got our function notation, f of x, right? So if f of x is the function, then the inverse, let's write this out in words on here. So let me just add it to this. The inverse of f of x is f prime of x. Okay, so that is the notation for the inverse. Okay, so let's look at this with an example. I'm gonna do this video. I'm gonna kind of format this video really similar to the way I do things in class, where I do an example or two, and then I'm gonna put one or two up on the board, right, on the screen, and I'm gonna have you pause it and work it out on your own, and then unpause it and check the answer after that. So that's kind of the format we're gonna follow in this video. Try to keep it as similar to in class as we can. So let's look at a few examples. We're going to start with some fairly simple. So for example 1, if f of x is the set, right? Set notation is in curly braces, right? The set of these ordered pairs. 4, -10, 7, -19. Zoom out a little bit. And -5, 17, and 12, 3. Right? So if that's the function f of x that we're looking for, we want to find the inverse of f. So f prime of x. Right? Okay, so for a set of ordered pairs, it's really, really simple. All we do is say that f, do this in a different color to keep our notes neat, that f prime of x is the ordered pairs -10, 4, -19, 7, 17, -5, 3, 12. Okay, so that's all there is to that. In fact, that one is so simple that I'm fairly confident that one we don't have to do a guided practice example. I'll assign a couple of them for homework just to make sure that you got it, but that one is so simple that I think you got it, right? So let's kind of move up a notch and up a level, right? So let's look at this next group of examples. Whoops. Dang extra finger. Missing extra finger. I really think that's what happens there. Is it? See, it bumps even through my glove. I think it's just because there's enough pressure happening that it kind of skips ahead. But, life is a mutant, I suppose. So, if f of x is oh, I forgot that our textbook uses a different notation. We should make our notation match the textbook. F prime of x is a good one, but we're gonna use the same one that they use in our textbook. Instead of doing a tick mark, we're gonna do f minus 1, which is probably more common actually. So we're gonna use that notation. So instead of a tick mark, we're gonna use inverse. So here's our example. F of x equals 4x minus 6. And we're going to call this example 2, right? And we want to find the inverse of f of x. So this is what we do. These are the steps that we're going to follow. What we're going to do first is we're going to change f of x to y. Okay, so change it to y. Let me just make this a dark purple. That'll work. So y equals 4x minus 6. So in order to find the inverse, this is what we do from a equation. We switch the x and the y. So we take wherever there's a y, we put an x. Wherever there's an x, we put a y, right? Straightforward so far. So that's going to be x equals 4y minus 6. Really straightforward. Now, in order to get this and finish it out and make it nice and neat and usable, we're going to take and we're going to solve this guy for y. Okay? So we're going to, in order to solve this for y, we're trying to get y by itself, right? So we're going to first add 6 to both sides. Basically, we're putting this into slope-intercept form, right? That might be a good way to think about it to connect it to what we're doing. So we end up with x plus 6 equals 4y. I don't know why I stayed in pink, just did. It's fine. So we're going to divide both sides by 4. Divide both sides by 4. So then I'm going to switch this around so my y one is on the other side. So I end up with y equals x plus 6 divided by 4. Now, we could probably leave that answer where it is and just go with that, but we usually want to kind of finish this out and put it fully into slope-intercept form. And so we're going to divide that 4 into both of those terms. So y is going to equal 1/4 x plus 6 over 4. Now, 6 over 4, because we're going to graph it, we don't want to leave that. A, we need to reduce it, and B, we probably want a mixed number so that we can graph it and find that y-intercept a little bit easier. So 6/4, when we reduce that, is 3/2, right? Now 3/2 as a mixed number is 1 and 1.5. Okay, so this one is y equals 1/4 x plus 1.5. The last thing that I like to do is to finish this up and write this back in function notation and write f inverse, so the inverse of f of x equals 1/2 x plus 1/2. That's it. That's that simple. So let's do a couple other examples. So I'm going to put them up here, and then I'm going to have you pause the video and then do them on your own. Okay, so the first example we're going to do is going to be, what is this, example number 3, right? So example number 3. Example number 3, our f of x is going to be 4x minus 12. All right, so I want you to pause the video. I want you to find the inverse of f of x, and then I want you to come back to the video and we'll look at the way that looks once you actually do the work. So pause the video and then come back when you're done. So there it is. There is the answer and there's the work. You can check your work and see if you got the right answer. So if you got the right answer, you ended up with the inverse of f of x equals 1/4 x plus 3. Easy peasy lemon squeezy. So we took and we rewrote it with a y instead of the f of x. We switched them and ended up with x equals 4y minus 12. We added 12 to both sides to get rid of that. Then we divided by 4. I went ahead and jumped to divide by 4 on everything instead of writing with a big fraction bar, just to kind of save myself some writing, because it's even that's not really skipping steps, not really. Now, in case you're like, what is that? Remember, I like if I'm going sideways on a thing, I like to put an equals with an arrow to show that I'm doing the next step over there. So in case we forget what's going on there, that's what that is. I was just rewriting it in function notation. So there's that one. If you have any questions over any of these examples and all that kind of stuff, then make sure and ask those on Thursday as well. So the next problem that we're going to do is problem number 4. It's going to be another one that's real similar. We're going to do the same thing where I want you to pause the video after I write it down, and I want you to do the work, and then I want you to come back after the pause and check your work and make sure you're understanding what you're doing. So our next one is going to be f of x equals 1/3 x plus 7. So pause the video and then come back and we'll look at the answer and make sure you're understanding what's going on. So there is our answer for, I was setting something up. Hold on, let me flip my thing back around so I can write on my screen easier so it looks vaguely decent. Still not as good as writing on this thing as I am on paper, but we do our best. So this is the answer right down here, right? The inverse of f of x is 3x minus 21. Now, so when we did it, we of course rewrote it with y instead of f of x was our first step. Then we switched, then we switched them. That was our next step, of course. And then we went through and we solved for y, to put it in white, slope intercept. Those are the words I am trying to say. This last bit might be a little bit confusing, right? But remember, we've got a fraction that is multiplied on the y. Gosh, I don't know why my clicking is having so much trouble. Maybe it's this hole in my glove. I don't know. But whatever it is, what's going on here, of course, is that we have a fraction multiplied times the y, and to get rid of a fraction, we multiply by the reciprocal, and the reciprocal of 1/3 is, of course, 3/1. So that's what's going on there. 3/1 is just 3, of course. All right, so that's where we end up with our answer. So now, the very last thing that we want to talk about before I give you your homework assignment is that what is going on here graphically. So what is an inverse and what is really happening? So in order to take a look at that, we're going to switch to another application. If you've not looked at desmos.com, DESMOS, then that might be a useful resource for you as we do these graphing things. It might help you kind of get some ideas of what's going on with stuff and all of those things. And so let's take a look at these things. So this is the very first thing that we did. This was example number 3. And so example number 3, our graph was y equals 4x minus 12. So this blue line right there, right? And so that is our initial thing. Now, and then the inverse of that is this green line here, which is y equals 1/4 x plus 3. So graphically, what is going on there? I went ahead and put the parent function of y equals x on there as well in black. I also dashed it because it's not one of our functions that we're taking a look at. So what is going on? Well, the green one is the same as the blue one, but reflected across the line y equals x. So instead of reflected over the x-axis, so flip down into, let's see, let me bring back up my whiteboard. Give me half a second. So let me kind of see if I can sketch what's going on here a little bit. So what's going on? So normally we've talked about reflecting things over the x-axis. So say our graph was this guy. So if we took and we reflected that over the x-axis, then everything that was up here would go down there. So our new graph, I should have done the same colors as Desmos, but that's okay. So our new graph would be flipped down here. So it would go like this, right? If we were flipping across the x-axis. Well, the inverse doesn't flip across the axis. What it does is it flips across that line y equals x. Let me transition back over there. So we take it and we take this, we take the blue one, and then to get the inverse, we flip it over the line y equals x. So it flips over there. So everywhere, so if you kind of tilt your head sideways and look at it, it should be that green one and that blue one should be symmetrical along the line y equals x because they're flipped over that way. Let's look at the other two to kind of illustrate that even further. I'll put all four graphs on the screen in a second. All right, so the other one is, our first one was y equals 1/3 x plus 7. So the inverse should be flipped across the line y equals x. So when we take that, we flip it over, right? So we should be able to turn our head sideways, and we should be able to kind of see that the line is going this way. The other line is going to be crisscrossed straight that way, right? Something along those lines. Something. Let me pop it up on the screen. So say if you turn your head sideways and look at that graph, then it's the same thing reflected over. Let me put them all on the screen. I may even change, let me change the colors so we can get something easier to see. No, I don't want that. Oh, it almost worked. Oh, I don't know how well I can do this with, maybe it's going to work. Red, and then you can do it, machine. It's like, I don't want to do it. And purple. There we go. So green and blue and red and purple. So if you kind of take a look and kind of twist your head sideways and take a look at those, hopefully I'm still on the screen. I can't see myself on what I'm doing. I need multiple monitors and all kinds of fancy schmancy setup, but I don't have that. So here we go. So we look sideways and kind of look straight down there. It's each one of those inverses is the graph reflected over the line y equals x, and that's what's going on graphically. Okay, so that if you want some more detailed explanation of that and all those kind of things, then it might be useful to look at example 2 on page 264. So you can take a look at that for more detailed information. It's kind of hard to talk about out in this way and whatever else. It's kind of hard to wrap your brain around. It's actually easier to see once we talk about later, way later in the semester, when we start talking about quadratics and all these things, and we got a parabola that's instead of flipped up and down, it's flipped over this axis. And all of those things. So it may be easier once we get some other different types of functions to take a look at that. But that's what's going on there. So let me pause and write your homework down. Yay, homework. So there is your homework. We're going to do page 268, numbers 14 through 26 evens. It's not really a ton of problems, and they're all fairly easy, as you've seen from this stuff. We will jump back in. We will jump back in on Thursday. We'll take questions over this homework and take any questions over the last homework and go through all of that. And we'll get assigned a review and all of those things, kind of like what I talked about at the beginning of the video. So hope y'all enjoy this. Hope it made sense and you come prepared with questions on Thursday. We shall see you on Thursday.